All right, as part of our series on magnets, fields, and forces, we're going to talk a little bit about what happens to a charge when it moves into a magnetic field. And so we have this nice diagram from your textbook. And what you have to think about this as is like a ball on a string for mechanics. If you take a ball on a string and you whirl it around in a circle, similar idea. We've got a centripetal force holding the charge in, and that's going to be the magnetic force. And you've got the charge wanting to head off following its velocity vector, and the force pulling it in. And it wants to head off again, and the force pulls it back in, heads off, force pulls in, and it does this, and it goes around and around in a circle. And it can be a deflected arc and then go back out of the field, which is how they bend charges around in accelerators and things. Or back in the day when there was a cathode ray tube in your television sets and monitors, that's how they bent the beam inside the cathode ray tube. So it's all about moving those charges in some kind of a controlled arc or circle. So I have an example for you. All right, so now we're going to take a charge and have it move into a uniform magnetic field. And when this happens, the charge deflects, and it'll depend on which direction the force pushes the charge. If it's going to go to the left, to the right, up, down, you'll use your right-hand rule to figure out which way the force is pushing it. But in either case, it's going to make some kind of an arc or turn around and spiral. What you end up with is it makes a helical spiral if it gets caught in there. And so the centripetal force, which is the force making it move in a circle, is really the magnetic force. And so we think back to mechanics, and you have mv squared over r is the equation for centripetal force, and in this case it's equal to qvb. And so you can solve this for all sorts of different things, just figuring out what's going on. But if you wanted to find the radius, you would just rearrange the equation and get the radius of curvature of the deflection is the mass of the charge times the velocity that it's moving at, divided by the amount of charge times the magnetic field. And so here's our example. And so if we use our equation where we had mv squared over r is qvb, and in this time we're going to solve it for q. So q is equal to mv squared over r qv. Those q's go. So we have mv over r. Oops. Sorry guys. Should be a b. mv over rb. So q is equal to 2.7 times 10 to the minus 26 teeny tiny kilograms. 5 times 10 to the 6, there's our velocity, divided by our radius in meters. And then our field in Tesla. So we end up with a charge of almost 5 times 10 to the minus 19 coulombs.